Yesterday we talked about the definition of a positive exponent, and today I'm going to show you a couple helpful shortcuts for working with positive exponents. The first shortcut, or property, is called the odd-even-negative rule. So, -2 when raised to the 6th power, what that equals is -2 times -2 times -2 times -2 times -2 times -2. So, all those negatives, there's a total of 6 of them. And if we wrote them out, negative times negative would be positive, times negative is positive, no, negative, it'd be a nightmare to try to figure out how many of them there are. Now remember that negatives cancel themselves out in pairs, and for that reason, if there are ever an even number of negatives, then they're all going to cancel out, and your answer will end up being positive. In the second example, where there's an odd number of negatives, most of them will cancel out, but there will be one left over that doesn't have a partner to cancel out with, and so your final answer will end up being negative. In short, if there are an even number of negative factors, your product will be positive. And if there are an odd number of negative factors, your product is negative. So, in this first example, -2 times the 6th, -2 raised to the 6th power, since there are 6 factors of negative, those all cancel out, and my answer will be positive, and 2 to the 6th power is one that I remember is 64. In this other example, -2 raised to the 3rd power, there's an odd number of negative factors, and so that works out to be a negative answer. And 2 times 2 is 4, times 2 is 8. So -8 is my final answer. Now, another useful property for exponents is that you can often add them together. Whenever your bases are the same, you could write out all these. There'd be x times x times x times x times x. That's x to the 5th. And x times x times x is x to the 3rd. And then we could count them all up. And there's a total of 8 factors. And so that's why the simplified answer for this is x to the 8th. But if you notice, if I just took the exponents 5 and 3 and added them together, I would have gotten an 8. Now, for small examples like this, it probably wouldn't matter. You don't need that shortcut. But for larger examples like this, it would save us a whole lot of writing to know that I could just add up all these exponents and figure out how many total factors of m there are. In this particular example, there's 33 and 42. That's 75 m's just in these first two alone, plus 100 more factors of m. And so this works out to a total of m to the 175th power. In general, when you multiply powers with the same base, you can add their exponents. And that's what this formula means. X to the a times x to the b is equivalent to x to the a plus b. Finally, when you've got a power that's raised to another power in a group, for instance, a very useful shortcut is that you can multiply the exponents. If I actually wrote this out, this would be m to the 6th times m to the 6th times m to the 6th. Or if I wrote out all of the m's, it'd be m times m times m times m times m, and so on and so on. How many of them would there be in total? Well, there'd be 6 plus 6 plus 6 for a total of 18. And that gives us an answer of m to the 18th power. And notice that's exactly what we would have gotten if we would have taken these exponents and multiplied them. Now in this example, there's a little bit more going on. There's a's that are raised to a power and b's raised to a power. And that whole combination of a's and b's is being raised to the 6th power. You could, again, write this all out. And in fact, I often do because I forget these rules or I get them mixed up a little bit. But the shortcut is instead of writing it all out, I could take this 6 and multiply it by each of these exponents. I often think of this as the distributive property of exponents. 6 times 2 gives us how many total a's there are, and 6 times 3 gives us how many total factors of b there are. That works out to a to the 12th power times b to the 18th power. In general, when you're raising a power to another power, you can multiply these exponents when you're working across the parenthesis. So x to the a raised to the b power gives us x to the ab.